So now we're going to see how to do the big computation for this section, which is to make a confidence interval. And I'll say to put a cap on the stuff with t-distribution critical values. I'm not going to ask you to compute those specifically very often. They may come up on the homework a couple times, but with the calculator vagueness, we're going to focus on the main stuff here, where in this case we're looking at college admissions with a sample of 20 students, so n equals 20 and the df is 19. The mean from the sample, x bar, is 22.9, and we have a standard deviation for this s of 1.5, where we want to make a 90% confidence interval. Now we can do this more or less by hand, setting up all of these pieces where we have to get that critical value, as it were, and sometimes in the homework they'll ask for all these steps here and then get the margin of error, or add and subtract and get the interval. Or we can see how to do this in the calculator using the t-interval computation. So for that, you hit stat, and then scroll over to tests. And this is what we're really going to be using for most of the next few chapters, is this tests menu, where from there we go down to t-interval. Looks like it says tinterval there. And we're going to make sure that we have the stats option selected. The nice thing here is with the 83 and the 84, I think the menu is basically the same. And in here, we're going to put in that mean value, x bar is 22.9. The value for s is 1.5. And our, I want to put a plus sign in there. I hit the wrong button, should hit enter. The sample size is 20, which means we have 19 degrees of freedom if you prefer. And we're working for this with a, just to be sure, 90% confidence level. And as a result, it's going to run its numbers. It takes a little bit longer for the t stuff because the t's take a little bit more subtlety, but we will get our interval from 22.3 to 23.5, where we should be careful to say here that we've got 90% confidence that the mean's going to be between these values. But just to be sure, we're not quite saying that there's a 90% chance that the actual mean's in there, as much as we're saying that if we draw enough samples here and we carefully run them every single time, 90% of them will contain mu. So for our second example here, we're going to see how to do a t-interval computation where we're just given data. And this is, in my opinion, the more reasonable type of computation, where you just have a data set and want to make some sort of distinction using it, where here we want to get a 95% confidence interval, where what you're going to do is go to stat, edit, and then go through the terribly exciting process of plugging in all of these numbers, where once we get past the basic hang-ups of seeing how to do this stuff, this is by far the hardest part of most of our problems, is making sure we get all of this stuff in here accurately and in a reasonable amount of time. I cut that part out here just because, well, you know, it would just be too much excitement, obviously. But once your numbers are all in, what you do is you hit stat again, go back to tests, and find your new friend, the tinterval, that is the t-interval, where now we're not working with stats like we were in that previous one. We're going to work with data, where we have our list in list 1. There's only one frequency, we're not going to mess with that, and we want to get a 95% confidence interval. And the nice thing here is that if you have a data set, you don't have to worry about tracking around any other information. Just make sure the data set goes in there correctly, have it run the computation, and you get the desired confidence interval. It's really just that simple. And we're going to get one more quick example in here because it's in the PowerPoints. I'm not going to talk about it in the other videos, but you might as well have it just for reference. So for this one, we're looking at coffee. So we got these 16 shops where the mean temperature is 162 degrees Fahrenheit with a standard deviation of 10, and we want a 95% confidence interval. This one's just a bit of confirmation for what we do. You hit stat, tests, find the t-interval option at number 8, so you could just press number 8 if you want it, where we have stats here because we're given this information. Ignore this stuff that's from the old work. We have a mean of 162, a standard deviation of 10, sample size of 16, and a confidence level of 95%. 95% is a very common confidence level that we'll work with a lot. And you may ask yourself, could we convert this to Celsius? Sure. We also convert it to Kelvin if we want, but mathematicians aren't in the practice of giving themselves more work than we need to, so we're just going to stick with what we've got. And running that, we're going to get that margin of error type flavor, but really, we get our confidence interval.